Okay, the third property that we are going to discuss is multiplication by t power of n. So this property says that if we have a function ft here, if we have a function ft that is multiplied with a t power of n, okay, this is specific for any function in the form of t, in terms of t, but specifically multiply to the t power of n. Then the transform is says to be in the form of this. Okay, negative 1 power of n dnf dsn. Okay, so this term here is actually derivative. Okay, derivative of f with respect to s. Okay, so it means if we know the fs, then we can get the derivative here. All right. So in example 6 here, we want to find the Laplace transform to function t sine 6t. So this term here can be seen as t power of 1, okay, multiply with some function ft. Okay, so this term here can be mapped to the property of Laplace transform of t power of n times ft. So the answer is supposed to be in the form of negative 1 power of n dnf dsn. Okay, so if we refer to the table, this property is stated here. Okay, so if we have a function ft multiply to the t power of n, then the answer would be in this form. Okay, so back to this. So if we map our problem to the t power of n times ft, then we know that our n equals 1. Okay, t power of 1. And the function ft is sine 60. All right, so the intention is actually, okay, to get this one. But in order to find the derivative here, first we need to know what is the fs. Only then we can differentiate. Okay, so we want to get the fs. So we know fs is the Laplace to the ft. Okay, which is the Laplace to the sine 60. Okay, so based on the table, the Laplace of 60, sine 60, so we need to refer to this. The Laplace of sine 80 is given by a over s squared plus a squared. Okay, so since we have 60 here, then the answer would be 6 over s squared plus 6 squared, which is 36. All right. So this is our fs. Okay, so if n equals 1, then we are actually looking for df ds. Alright, so you can see if n here is 2, then we need to get d2f ds2, which is the second derivative. Okay, so the higher the n here, so it means more works to get the derivative. Okay, because n basically referring to how many differentiation, how many times, okay, do you need to perform the differentiation. Okay, so for this one, n equals 1, so we only need df des. Okay, so based on the f, so it means we want to differentiate. So if I rewrite the fraction, I can put 6 times s squared plus 36 power of negative 1, so that I can perform the differentiation directly. So differentiate the term in the bracket. So I have negative 1 in the front, so negative 6 s squared plus 36. Now the power becomes negative 2. Okay, negative 1 minus 1. But don't forget we need to differentiate s squared, so we have 2s. okay, which can be written as, okay, 2 times 6 is 12, so we have negative 12s over s square plus 36 square. That is df ds. Okay, but our answer is supposed to be df ds times negative 1 power of n, which is negative 1 because our n is 1. Okay, so therefore the final answer then supposed to be, okay, Laplace of t sine 6t then is negative 1. Okay, don't forget negative 1 power of n is 1, so we have negative 1, times the df ds, so we have negative 12s over s square plus 36 square. So this is our answer, which at the end can be written as positive because we have negative times negative, so 12s over s square plus 36 square. Okay, this is the final answer. So that's how we apply this property, the multiplication of t power of n, okay, to this problem. All right. So the common mistake in the exam, students tend to stop here. Okay, they forgot that the final answer is supposed to be the derivative multiply, okay, to the negative 1 power of n. Okay, so don't forget. So I would suggest every time you have the problem, state or write carefully, okay, what is the mapping, okay, map to which property in your table, okay, so that you can see clearly at the end, okay, what's supposed to be your answer at the end. All right. Okay, in example 7, we want to find the Laplace transform to the exponent of negative a and negative t times sine 2t. So actually we have 3 terms in the bracket here. Okay, so let us see what we have so far. All right, so before this, we have the first shifting property, which says that the Laplace transform of exponent at times any function ft is given by fs minus a. And we also have the property of multiplication by t power of n, which says that the Laplace of t power of n ft is given by negative 1 power of n dnf dsn. Okay, the derivative. All right. So for this example, we have exponent negative at. Okay, but we also have t, okay, times a function sine 2t. So we can, you can see these 3 terms here. You can map to either one. You can map to the first shifting, or you can map to the multiplication by tn. Okay, so you can do both. This is the example where we need to apply 2 properties to solve one problem. All right, so you can choose if you want to refer the problem to be as exponent atft. So you will look, if you want to refer to this, then you will have a equals negative 1, then ft to be t sine 2t. Okay, if you want to map to this one, then your n is 1, t power of n, then the ft would be the other 2 terms, okay, other than the t. Okay, so ft would be exponent negative t sine 2t. Okay, so you can choose either one because along the process, okay, regardless which one do you map at the first place, okay, so in the process you need to apply both. All right, so in this discussion, I'm going to map to the first shifting first, okay, and in the process, we apply the multiplication by t power of n. All right. So I'm going to write this way. Okay. So the Laplace of exponent negative t sine 2t, I'm going to map to right. I'm going to map to can be mapped to Laplace of exponent ATFT, where the answer is supposed to be Fs minus A. Okay, so by mapping to that, then I know that my A is -1 because I'm mapping exponent negative t to the exponent AT. So A is -1, so the other two terms is Ft. So Ft is t sine 2t. Okay, so in order to know Fs minus A here, so first I need to know what is my Fs. Alright, so it means that therefore Fs is the Laplace to the Ft, which is the Laplace to the t sine 2t. Alright, so now you can see to find the Laplace of t sine 2t here, we need to apply this one because we now have t power of 1 times the ft, which is sine 2t. So if I put aside that Laplace, so I'm going to put in the table here, so in the box here, so that you know the separate thing. So the Laplace to the t sine 2t. Okay, if I take out that term, then I know that this transform here can be mapped to, okay, can be mapped to Laplace of t power of n ft, okay, which is -1 power of n dnf dsn. Okay, so I'm going to map to that one. All right. So by mapping t power of 1 to t power of n, so then I know my n is 1. Okay, and my ft is sine 2t. But you should know that this ft here is not similar to this ft. Okay, so you should bear in mind that, okay, what we have in the box here, okay, is your separate process, okay, separate calculation to get the Laplace of t sine 2t. All right. So in order to get the derivative here, first I need to know my Fs. Okay, Fs according to, okay, the function in the box here only. Okay, so the Fs, okay, is the Laplace to the Ft, which is the Laplace to the sine 2t. So based on the table of Laplace, you can refer to the sine at. So the answer is 2 over s square plus 2 square, which is 4. Okay, so that is Fs. All right, but the answer is supposed to be in this form. All right, so the Laplace of, okay, so what we want to get is Laplace of t sine 2t. Okay, so according to the map that we have, it is -1 power of n, so our n is 1. Okay, so we need to differentiate, okay, once, okay, dds to the function fs. So we need to differentiate 2 over s squared plus 4. Okay, so we have here okay, derivative of this one. Okay, so it means we differentiate, we have negative here, -1, we differentiate 2s squared plus 4 power of negative 1. Okay, so I have negative 1, and then the derivative is negative 2s squared plus 4 power of negative 2, and then I have 2s. Differentiate the s squared, so I have 2s. Okay, which is, okay, I have negative 1 and negative 2 times 2s. So at the top I have 4s over s squared plus 4 power of 2. Okay, so this is the transform to the, okay, t sine 2t. But this is not our final answer. Okay, we need to go back to this one. Okay, so the answer is supposed to be for this one. Okay, so if we go back to that one, okay, so our fs is 4s over s squared plus 4 squared. Okay, so therefore our original problem is the Laplace to the exponent negative t sine 2t. Okay, so at the first place it is mapped to fs minus a. Our a is negative 1. Okay, so this is our a. So this is actually fs plus 1. Okay, so since we know that fs is 4s over s squared plus 4 squared, then fs plus 1 is basically, we just substitute s with the s plus 1. So write carefully. So we have 4, s now is s plus 1 over, okay, s squared is s plus 1 squared plus 4. Okay, and outside we have power of 2. So this is the final answer. So careful with the bracket and also the power. Okay, so you can try, okay, on your own. Okay, you can try with this one first. Okay, so you can try with the mapping to this one at the first place, and along the process you apply the first shifting property. Okay, so you will see at the end the answer is supposed to be the same as here. All right, so take some time to go through again the solution, okay, and make sure you can understand, okay, every single bit of it. All right.